Hi everyone, welcome to the second session of the adsorption. Myself Sumalata S, Assistant Professor from the Department of Chemistry, SKNG GFG College, Gangavati. In this session, we will going to discussing about the concept of multi-layer adsorption, BET theory and equation, and finally determination of surface area of the adsorbent. Okay. Let's begin the session. Multi-layer adsorption. What is the mean by multi-layer adsorption? Multi-layer adsorption is a phenomenon where more than one layer of molecules can adsorb onto a surface. Unlike mono-layer adsorption where only single layer forms. Okay. See here what happens, only single layer of adsorbate molecules accumulate on the adsorbent. But in case of multi-layer, what happens, there is a more than one layer. This is a one layer, this is a one more layer. Okay, so more than one layer of a molecules can adsorb onto a surface. That is called as a multi-layer adsorption. Okay. And here what happens, the factors which are influencing the multi-layer adsorption. The first one is the surface properties. What are the surface properties? Means nature of the adsorbent surface can affect the extent and type of the multi-layer formation. Means it's the surface porosity and roughness which can affect the extent of the multi-layer formation. Next is the adsorbent properties. Adsorbent means the molecules are the atoms which are going to accumulate on the surface. Those are termed as adsorbate. The type of the adsorbate molecule and its interactions with the surface and other adsorbate molecules play a crucial role in the formation of the multi-layer. The third factor is the temperature and pressure. What happens here? If the higher the temperature and pressures, this can favor the multi-layer adsorption as they increase the likelihood of a molecules colliding with and sticking to the surface. Okay. At the higher temperature and pressure, this can favors the multi-layer adsorption. And how it favors means because they can increase the collision of the molecules and sticking to the surface. Okay. Next, BET theory. What is this BET theory? The Brunner, Emmett and Teller theory is a widely used model for describing multi-layer adsorption of a gases on solid surfaces. It assumes that the first layer is formed by stronger interactions with the surface. First layer is formed by the stronger interactions with the surface, while the subsequent layers are formed by weaker interactions between the adsorbate molecules. Okay. Means here what happens, the in case of single first layer, there is a stronger interaction between the adsorbate molecules and the adsorbent surface, while the successive layers are formed due to the weaker interactions between the adsorbate molecules. Okay. Here it extends Langmuir model to account for the multi-layers of the adsorbed molecules. Means Langmuir model is used to describe these multi-layers here. This theory is widely used to determine specific surface area of the materials. Okay. Here multi-layer adsorption means, unlike the Langmuir model, BET theory assumes that gas molecules can adsorb on top of each other, means forming the multiple layers on the solid surfaces. Okay. And means first one is the multi-layer adsorption. Means unlike the Langmuir model, the BET theory assumes the molecules, adsorbed molecules, which are forming the multiple layers on the solid surfaces. The second one is the infinitely many layers. Means the theory postulates that adsorption can occur in an infinite number of layers on the surface. Means either it may be 2 or 3 or any numbers. Okay. So that is the infinitely many layers can formed on the surface. And third one is the Langmuir model for each layer. Means each layer is treated as if it were undergoing Langmuir type of adsorption, with the first layer having different heat of adsorption than the subsequent layers. Means the Langmuir model is applied for each layers. Those are accumulate on the adsorbent. Okay. Next, fourth one is the first layer adsorption. Means the first layer of adsorbed molecules is assumed to have a specific heat of adsorption that is different from the heat of liquefaction of the gas. Okay. And fifth one is the subsequent layers formation takes place. Here the subsequent layers are assumed to have a heat of adsorption equal to the heat of liquefaction of the gas. Okay. The first layer is here, in case of first layer, the specific heat of adsorption is different from that of the heat of liquefaction of gas. While in case of subsequent layers, the heat of adsorption is equal to the heat of liquefaction of the gases. Okay. These things about the BET theory. Next, assumptions of the BET theory. What are the main basic assumptions of the BET theory? The adsorption occurs in layers on a uniform surface. Okay. This theory assumes that adsorption takes place on the uniform surface. There is no interaction between the adsorbed molecules in different layers. Why? Because this theory applies the Langmuir model for each layer. Okay. So in case of Langmuir model, what is the one of the criteria? There is no lateral interactions between the adsorbed molecules, right? So that is, this theory also assumes that there is no interaction between the adsorbed molecules. And third one is the Langmuir model can applied to each adsorbed layer. Fourth is the heat of adsorption for the first layer is constant and it is different from the heat of liquefaction of the gas. Okay. For the first layer, heat of adsorption is a constant one and this is different from the heat of liquefaction of the gas. While for the subsequent layers heat of adsorption is equals to the heat of liquefaction of the gas. Okay, the first assumption is adsorption, there is a uniform surface. Second one is there is no interaction between the adsorbed molecules in different layers. Third one is the Langmuir model can be applied for the each layer. Fourth one is the for the first layer heat of adsorption is different from the heat of liquefaction. Fifth one is for the subsequent layers behind the first, that is heat of adsorption is equal to the heat of liquefaction of the gas. So these are the assumptions of the BET theory, and the equation mathematical expression for the BET theory is given by P divided by V into P naught minus P is equals to 1 divided by Vm plus C minus 1 divided by Vmc into P divided by P naught, where V is the volume of the gas adsorbed at the pressure P and temperature T, and P naught is the saturated vapor pressure. Vm is the volume of a gas for the monolayer formation, means for the first single layer formation how much volume of a gas required, that is represented as a Vm. The total volume can be represented as a V itself. And C is the constant and its value is given by the exponential of E1 minus EL divided by RT at the constant temperature T, and R is the universal gas constant, and E1 is the heat of adsorption of a gas for the formation of monolayer, and EL is the heat of liquefaction of the gas. Okay, for the first layer this E1 is different from the EL. For the subsequent layers this E1 equals to EL. Okay, this is the BET equation, and this is of the form Y equals to mx plus c, right? This is of the form linear line equations. Here this is the y axis component and this is the x axis component, and here m is the slope and c is the intercept on the y axis. Okay, from this the slope value is c minus 1 divided by Vm divided by c, and on the y axis intercept its value is given by the 1 divided by Vm into c. Okay, the plot of this BET equation is given by the this is okay. Here this is the y axis component, this is x axis component. From the equation we comes to know that this is the slope and this is the y axis intercept. We can have the straight line. Okay, next from this the surface area can be calculated as Vm into Na into S divided by V. Vm is the volume of gas required for the monolayer formation. Na is the Avogadro number and S is the effective surface area available for the monolayer formation, and V is the total volume of the gas adsorbed on the adsorbent at STP, standard temperature and pressure. Okay, this is the surface. By substituting these values we can know the surface area of the adsorbent molecule. Okay, and next determination of surface area of the adsorbent. Okay, this is a one more other method for the determination of surface area of the adsorbent molecule. Here, since the molar volume of a ideal gas at the STP is given by the 22.414 dm cube. The number of molecules N are adsorbed corresponding to the volume V mono, means formation of the mono layer. Then N is number of gas adsorbed. N is given by the V mono divided by 22.414 into 6.023 into 10 to the power of 23. This value is the Avogadro number. And now if the area of cross section of a single molecule is known, it can be multiplied by above number to give the total surface area of the adsorbent. Okay. Yeah, now if rho is the density, then volume V occupied by a single molecule is given by rho equals to m divided by Vm, which is equals to m divided by V into Avogadro number Na. M is the molar mass of the molecules of gas adsorbed on the surface. Okay. And Na is the Avogadro number. Then V equals to volume V equals to m divided by Na into rho. Okay. Next, assuming the molecule to be spherical, its cross-sectional area can be computed as follows. If R is the radius of the molecule, then it is given by the volume V equals to volume of the spherical molecules is given by the 4 by 3 pi r cube. From here we can know by substituting the V value from the previous equation, that is m divided by Na into rho. By equating these two equations, we can have R equals to 3 divided by 4 pi into m divided by Na rho whole to the power of, here cube is present. If it comes this side, means it becomes 1 divided by 3 to the power of 1 by 3. Okay, so this is the value of R. And for the cross-sectional area A of the spherical is given by the area A equals to pi r square. We know the value of R. Substituting that R value in this expression, then we get the area. Pi into 3 divided by 4 pi m divided by Na into rho whole to the power of 2 by 3. This is the area of the adsorbent. Okay. From the end of this session, we came to know that the multi-layer adsorption, BET theory expression, mathematical expression and plot of the BET theory, then surface area, determination of the surface area of the adsorbent. Okay. From the end of this unit, we understood that we learnt about that Langmuir adsorption, isotherm, multi-layer adsorption, BET theory and determination of the surface area of the adsorbent. Thank you for watching.